I'm recording. Screen share. Okay. So here a two-wire DC system is to be converted into a three-phase AC system, three-phase AC system by adding a additional third conductor of the same cross section. That means same width, same length, same width, same cross sectional area as the two existing conductors. Calculate the percentage. Calculate the percentage additional load which can now be supplied if the voltage between the wires and the percentage loss in the line remains same. That means your voltage and the percentage of loss should be equal or remain unchanged. Assume a balanced load of unity power factor. Now this one, figure 7.25 shows two-wire DC system. Here, this is your two-wire DC system. One current is going, current is coming back. That means this is positive, this is negative, and the voltage between them is V. Voltage between them is V, right? Okay. Now here, this one is three-phase, three-wire system. This is AC system. This is I2, this is I2, this is I2. Now, voltage between these and these are V. That means one phase and another phase is V. One phase to another phase is also V. This phase and this phase is also V. That means this is a balanced load. So A to B is V, B to C is V, and A to C is also V. That means voltage in between two conductors are V. Okay. Now, suppose V is the voltage between conductors for for the two cases. Let R be the resistance per conductor in each case. That means R is the resistance of per conductor. In one conductor, the resistance is R. So let's come here. For two-wire DC system, that means the first one, the power supplied is equal to P1 is equal to VI1 because the voltage is V in both cases and I1 is I1. So VI, that means V into I1. And the power loss here will be 2I square R. Why 2? Because you have two conductors. Why I1? Because it is the current here is I1. What is R? R is here for one conductor, the R is R. 2I square R. That means I1 is square R. So percentage of loss. What is the percentage of loss? Percentage of loss will be line loss divided by total power into 100. That means the upper portion is the line loss, lower portion is the total power into 100. That is the line loss, percentage of line loss. So 2I1 square R divided by VI1 into 100%. That is your first percentage of loss. For the second one, what is your power supplied? Remember, right now this is not DC, this is AC. Obviously, there should be a √3 because of the RMS factor. √3, that means the line and phase factor actually. P2 is equal to √3 VI2. Obviously, for AC, for DC, it was VI. For DC, for three phase, it is √3 VI. What is your line? What is your power loss? Power loss should be 3I2 square R. Okay, somebody wants to come. It is 3I2 square R. 3I square R. Why 3? Because you have three conductors. That's why. 3I2 square R. So the percentage of line loss will be 3I square R divided by √3 VI2. That is the thing. That means the upper one you have the total power loss, the lower one you have the total power. Remember, percentage of line loss will be power loss divided by total power. Power loss divided by total power. That is your percentage of line loss. Since they are all equal, why equal? Because in the question they said the power loss should be equal. Since the percentage of power loss is equal, so first one and second one should be equal. Hundreds are gone. V and V are gone. R and R are gone. So what you are, okay, here you have I1, here you have I1 square, they are gone. Here you have I2, you have I2 square, they are gone. So what you are left with? 2. You are left with 2. That means this one. 2 I square R. and you are left with 1I1. Why they both of them are selected, I do not know. Okay, 2I1. Here you have 3I, root 3I, because you have root 3, you have 3, so they will be gone, and you have only one root 3, root 3I2. So only left thing are there, 2I1 is equal to root 3I2, right? Now here, from there you, okay, what we have to find out, let's see again. We have to find out, calculate the percentage of additional load. What is the additional load? Additional load means how much power is being dissipated more. That means the P1, okay, how big your P2 is. P1 was VI1 and your P2 is root 3 VI2. You have to make us understand how much bigger the P2 is or P1 is. We have to understand. So before that, we have to see how much your I2 is bigger. So your I2 is 2 by root 3 into I1. 2 by root 3 into I1, right? That is your I2. Now P2 divided by P1, that is the percentage, not the percentage, that is the ratio. P2 divided by P1. So your P2 is root 3 VI2 and your P1 is VI1. Here V and V are gone. In place of I2, you write 2 by 3, 2 by root 3 I1. Your root 3 gone. Your I1 gone. You have V and V are gone, and you are left with only 2. That means here. That means your P2 is equal to 2 P1. That means you can supply twice the power. You can supply twice the power if you convert your two-wire DC system to three-wire AC system, three-phase three-wire AC system. That means by adding only one conductor, you can supply double power. That means 100% more. By adding only one conductor in your system and going from DC to AC, you can supply double power. That means 100% additional power. So that is the additional power which can be supplied at unity power factor by three-phase three-wire AC system is 100%. বুঝতে পারছি? দেখো আমি বাংলায় বলছি, সেটা হচ্ছে যে আমার P2 হচ্ছে 2P1, তার মানে হচ্ছে আমার আগের পাওয়ারের থেকে ডাবল পাওয়ার সে সাপ্লাই করতে পারবে। That means he can supply additional 100% more. আগে ছিল 100%, এখন সে 200% সাপ্লাই করতে পারবে। তার মানে হচ্ছে সে 100% বেশি সাপ্লাই করতে পারবে। তো তুমি যদি টু ওয়্যার ডিসি সিস্টেম থেকে থ্রি ফেজ থ্রি ওয়্যার এসি সিস্টেমে কনভার্ট করে ফেলো, তার মানে মাত্র একটা ওয়্যার তোমাকে বাড়াইতে হবে। এই একটা ওয়্যার বাড়াতে পারলেই তুমি কিন্তু 100% বেশি পাওয়ার সাপ্লাই করতে পারবা। দেখো তোমার you have two-wire DC system and you are supplying 100% power. Now, if you want to supply 200% power, you need to add two more wires, two more DC wires, right? So two for 100%, and other two are for another 100%. Now, if you add one conductor only, not two, and if you convert your AC to DC, no, DC to AC, you can achieve that 100%. Understood? I believe you understood. So the additional power is 100%. So this is one math. So you can actually do lots of math from here and practice those math. And there is one, what is that? Practice all of the math, and you have some tutorial math here as well. Tutorial math. You have some tutorial math. You do them as well. Now come to this one. The element of transmission line. Elements of transmission line for the okay. Wait a minute. Let me stop the share. Elements of a transmission line for a reason associated with the economy. The transmission line of electric power is done at high voltage by three-phase, three-wire overhead system. The principal element of a high voltage transmission line are conductors, step up and step down transformers, line insulators, support, protective devices, and voltage regulating devices. That means, remember, you have 6 elements in your transmission line. One, very important, conductors, because that is the most important part. Without conductor, how can you transmit the power, right? Okay. Now you have to understand the transmission of electric power is done at high voltage by three-phase, three-wire system, overhead system, normally. So the conductors are important, usually 3 for a single circuit line and 6 for a double circuit line. That means normally three-phase, three-wire system, you need 3 wires for a single circuit, and you need 6 wire for double circuit. That means double the power. The usual material is aluminum reinforced with steel. The usual material is not copper. Remember, it is not copper. It is aluminum reinforced with steel. Reinforced means in the middle you have a steel core. In the middle you have a steel core. Outside you have aluminum. That is your conductor. Normally, step up and step down transformer. Obviously, to transmit the power in high voltage, you need to step up the voltage, and for uses you need to step down the voltage. Okay, so you step down and step up transformers are important so that you can transfer the power or transmit the power efficiently. The line insulators, obviously line insulators are important, which mechanically support the line conductors and isolate them electrically from the ground. You need to have some towers, right? You need to have some support for holding the conductor with the tower, because towers are metal and metals are placed metals are what is that, situated on the ground, and so that your conductor do not touch the ground, you need to separate them from the from the support from the tower. You need to separate them. How do you separate them? You need to use some insulators, line insulators. So remember, in our transmission and distribution course, we have a very big topic on insulator, very big topic. So we will learn about insulator more in our subsequent classes. Line insulator, which mechanically supports the line conductors and isolate them electrically from the ground. Support, which are generally steel towers and provide support to the conductors. Remember, supports means towers, right? Steel towers, and those actually hold your conductor on top of your head. Protective devices like lightning arrestors, circuit breakers, ground wire, relay, those are actually protecting devices. What do you mean by lightning arrestors? Lightning arrestors are some devices that actually helps you to discharge the huge voltage what produces during the lightning, because our conductors are way above our head and it is situated, let's say, 50 meters above the ground, or 60 meters or 100 meters above the ground. That means that is closer to the sky. So when there is a lightning, most likely it will fall on top of our what is that, our cable, right? Our overhead cable. So when it falls on top of the overhead cables, the huge voltage must be discharged to the ground. Otherwise, it will damage all of your appliances, all of your fridge, TV, everything else, right? It will damage. So how can you protect your devices from the huge lightning bolt? By using lightning arrestor. What is lightning arrestor? Lightning arrestor is actually this one. Okay, let me show you something. No, not that. Yeah, this one. This is actually called lightning arrestor or surge arrestor. You have seen this already, right? These are not your insulator. These are actually, you have seen this already. So what happened here? See, in every line, they have some this sort of arrestor. Can you see that? So with the tower, they are connected, right? You have seen some sort of arrestor here. You have seen it, right? Some sort of thing. These are not insulator. Remember, these are not support. These are lightning arrestor. What happens when? Okay, here. What happens here? Look at this picture. If there is a lightning, let's say here there is a lightning, right? If there is a lightning here, this voltage should not go to the consumer end. It should go to the lightning arrestor, to the tower, to the ground. Okay, understood? So when there is a lightning here, so it should go through the lightning arrestor to the ground. Understood? That means if there is a lightning here, so the voltage, the huge voltage, will go to the lightning arrestor through this wire to the ground. Normally the lightning arrestor has a resistance of infinite resistivity. So they are not connected. So you can ask me, sir, why they are connected? If they are connected, that means the voltage are going to the ground, right? No. Normally the lightning arrestor, the resistivity is infinite. So there is no current flow inside, no current flow. But when the voltage rises, when the voltage is huge, that time the resistivity varies. That time resistivity becomes zero. That time the resistivity of the lightning arrestor. Remember, this is not lightning arrestor. These are actually insulator. This one is insulator. This one is insulator. This one is lightning arrestor. The insulators are hanging from the tower to the conductor. They are normal insulator, but this one is lightning arrestor. This one, not this one. This is insulator. This is lightning arrestor. Understood? This is lightning arrestor. So what happens? Normally the resistance is infinite when the voltage is low. When there is a lightning, that means the voltage is million volt. That time the resistivity becomes zero. That time all the voltage can discharge through the tower. That's why always remember, when there is a lightning or whatever something is happening, do not touch any transmission tower. Do not touch, because there might be a lightning arrestor. When there is a lightning, that huge voltage can go through the tower. So that is dangerous. Okay. So that is a lightning arrestor. Support means tower, is actually tower. Protective devices such as ground wires. Okay, we have already talked about that. Voltage regulating devices like receiving end with permissible limit. Voltage regulator means it actually measures the voltage and it regulates the voltage, which are situated at the end of your transmission line. That means the receiving station or the substation. When the voltage goes up or goes down, it controls the voltage. And the economics of power transmission. Now we are not going to talk about that. You can read it by yourself. This is completely a topic of economics. The cost calculation. No need for our tiny syllabus. Okay. Requirements of satisfactory electric supply. Requirements of satisfactory electric supply. Remember, the electric power system in India and Bangladesh is 3-phase AC operating at frequency of 50 Hz, obviously 50 Hz. And how can you call a electric supply system reliable or requirement? So you have to understand the voltage regulation. Your voltage regulation should be top notch. A voltage regulation has a large effect upon the operating of both power machinery and lights, obviously, because if your voltage goes up and goes down, it is not good. It is not good for your machinery. It is not good for your light, because your motors will be damaged. Your motor is designed to have its best characteristics at the rated voltage, and consequently a voltage that is too high or too low will result in decrease in efficiency. Obviously your motors, that is your fan, your motors, and your everything else, they will work best in rated voltage. That means the fixed voltage, right? And if your voltage goes up too high or goes down too low, it will result decrease in efficiency and in lifetime as well. If the fluctuation of voltage are sudden, there may be cause of tripping of circuit breakers and consequent interruption of service. That means if the voltage fluctuations are sudden, খুব যদি তাড়াতাড়ি ভোল্টেজ বেড়ে যায়, তাড়াতাড়ি ভোল্টেজ কমে যায়, তাহলে ভোল্টেজের সার্কিট ব্রেকার ট্রিপ করতে পারে, সার্কিট ব্রেকার পড়ে যেতে পারে। That means তোমার সার্ভিস বন্ধ হতে পারে। Usually the voltage are generator terminal where this is done. In some cases the voltage variation at the load may be made sufficiently small by keeping the resistance of the reactances of the line and the feeders low. Normally the voltage regulation ta যেখানে where the voltage is created, in that place the voltage regulations are done normally, but there might be some exception as well. Dependability, obviously this is a very important topic. You must depend on your supply system. You can depend, right? If your supply system do not give you enough power on time, you cannot depend on it, right? For example, failure of power in hospital, in crowded theaters or stores, that may lead very grave consequences. Therefore it is duty of electric supply company to keep power system going to furnish uninterrupted service. That means in your hospital you must need 100% dependable power supply, right? You cannot have any sort of problem in your hospital. That must be one criteria, right? Obviously your supply company should give you uninterrupted power for 24 hours a day. So that is dependability. You can depend on your power supply company. Obviously Bangladesh do not have different companies, all of them are government, right? But in bigger countries they have different private companies as well, and you can choose whether I will take electricity from that company or that company. That company is good, that company is bad, so I will take my power from that company. You can choose, but in Bangladesh you cannot choose. All of them are government centric. Efficiency, obviously your efficiency should be higher, otherwise the loss will be there, right? Frequency, your frequency should be maintained or must be maintained. You need 50 hertz, that means it should be 50 hertz. It cannot be 52 or it cannot be 48. It should be maintained. Sinusoidal waveform, your waveform must be close to pure sine wave. It cannot be modified sine wave, or it cannot be square wave. It should be purely sine wave, otherwise your machine will be damaged. Your machine are designed for pure sine wave. That means if you do not supply pure sine wave, your machine must be damaged after some time. Freedom of inductive interference, freedom from, obviously your power should not interfere with some inductive interference. Okay, so self test, you have some self test there, you can take the test as well if you want. And I think we are at the end of our chapter. From the next class we will be dealing with mechanical design of overhead line. This is one of our very what should I say, very important chapters. Mechanical design of overhead line, very important chapters. We will not start it now, we will start in our next class. Very important and very what should I say, very important chapters, very important chapter actually. We will have in our midterm, we will have 70% question from here in midterm. Remember, 70% question from here. Okay, chapter 8. Understood? You can unmute yourself and you can say something.